Welcome to Section 2 in Neurology. This section will actually be split into two parts, and this is part 1. In this first video, we will be doing an overview of the spinal cord and the spinal cord levels. So let's get started. So here's figure 8.8 from your text. So let's identify the different locations that you need to know. And this is just a very basic overview. So you've got the cerebrum, which is discussed in section 1 of this chapter. You got the pons, that's labeled here, as well as the cerebellum that you can also see right there. And then the brainstem is important in this region, which includes the midbrain, pons, and the medulla. And then you have the medulla, which becomes the spinal cord in this region here. And then you'll notice the enlargements. You have a cervical enlargement because there's a lot of nerves that are going to the upper extremities. And then here in the lumbar region, you have the lumbar enlargement because there are a lot of nerves that are going to the lower extremities. At the very end, you've got the conus medullaris. So this is just a basic overview so we can get started with the spinal cord. So now let's take a cross-section of the spinal cord and focus on that. This is figure 8.9 from your text. And so what's important to know is that the spinal cord conducts information from the brain to the periphery, or from the periphery to the brain. Sensations such as pain, temperature, and touch will come from the periphery in through the dorsal root ganglion, and then come in. There will be some sort of interaction here, but ultimately, whether it goes up through this region or this region, we'll get into the tracks in a moment. But what's important to know is that the information travels up in this white matter. And it does this at every spinal cord level. Something else I want you to make sure you understand is that this inner dark blue part is the gray matter, and this lighter part is the white matter. So now we will show figure 8.10 from your text, showing each individual spinal cord level. Notice how the white matter increases in volume as you go up. This makes sense. The sensory axons in the white matter collect as you move up. So here at the sacral level, you have sensory axons coming in and then traveling up. And at the lumbar level, travel up, thoracic level, and the cervical level. So it makes sense that here at the top, in the cervical region, you have a lot more white matter. So on this left side in red, we've demonstrated sensory information traveling to the brain. And now on this right side, we're going to talk about motor innervation. So motor innervation from the brain travels down the brain through the spinal cord and then sends information to the periphery. And it does this through peripheral nerves. Now motor axons from the brain heading to the periphery are part of the white matter, as I've demonstrated here. They also contribute to the decrease in white matter as you descend down the spinal cord. In other words, you're going to have more white matter at the top as you continually lose the nerves heading to the periphery. So it's consistent with what we've demonstrated here with the sensory nerves. There's going to be more white matter at the top and less at the bottom. So notice how each level of the spinal cord has a distinct appearance. So let's actually erase all of this so we can take a better look at it. So it's very important to be able to recognize each of the 4 segments of the spinal cord. Notice how each spinal level of the spinal cord, whether it be cervical, thoracic, lumbar, or sacral, has a distinct appearance. So first, it's really important to just recognize that the cervical spinal cord has this wide appearance. You'll also notice that it has the most white matter, all is right, most white, and then thoracic level has the least gray matter, but it also has a lot of white matter. So you get this interesting appearance with a lot of white matter and this just skinny looking gray matter. And then the lumbar and sacral look very similar. So it's really helpful to recognize that the lumbar, of course, is going to be larger than the sacral. In fact, the lumbar and sacral spinal cord levels are so similar that it's really not fair to ask you a question about identifying just the lumbar or just the sacral spinal cord level in isolation. In other words, you're really going to have to see both of them, both the lumbar and the sacral, and be able to compare the size in order to really understand what you're looking at. Because sometimes the lumbar spinal cord level can look a lot like the sacral spinal cord level. They both have a lot of gray matter, and they've got the least amount of white matter. So you just need to compare them. Otherwise, just memorize the cervical and thoracic, and then memorize the lumbar and sacral together. So now let's talk about the pattern of spinal nerves as they relate to the vertebrae. So here's figure 8.11 from your text. So just remember that there are 8 cervical, 12 thoracic, 5 lumbar, and 5 sacral. We actually didn't show the sacral nerves here, so I'll just make sure that that's clear. So notice where each spinal nerve exits the vertebrae. The cervical nerves exit above their corresponding vertebrae. So here is C1 as labeled, the atlas, and you have the C1 spinal nerve would actually exit above that. So I'm drawing that in here. So I'll just write C1. And then you can see C2, which is labeled, and then the C2 spinal nerve will exit right above that. And this pattern continues until you get to C7. It includes C7. So if this is the C7 vertebrae, then right here is C7. Exits above the vertebrae. And then C8 actually exits underneath. So then the pattern changes from here on out. So this pattern continues from T1 to the rest of the spinal nerves. So every spinal nerve below T1 will exit below its associated vertebrae. So let's say a patient gets in a car wreck and a radiograph shows that the vertebrae down through C6 have shifted anterior to the vertebrae C7 and below. What spinal nerve is likely damaged? So the radiograph shows that these vertebrae, C6 and up, have shifted anteriorly. So we expect the nerve between C6 and C7 to be damaged right here. So we just need to know what nerve this is. Recall that in the cervical spine, the spinal nerve exits above its corresponding vertebra. So the spinal nerve exiting above C7 would be the C7 spinal nerve. Remember that from T1 and below, this pattern no longer exists. Instead, each spinal nerve exits below its corresponding vertebra. So starting here and down, we will get T1 under the T1 vertebrae, and the T2 spinal nerve, the T3 spinal nerve, and the T4 spinal nerve beneath the T4 vertebra. Now let's talk about the caudalmost portion of the spinal cord. This is figure 8.12 from your text, and this is anterior, and this is posterior. We can see from this image that the spinal cord actually ends around this portion, right here, between the L1 and L2 vertebrae. However, the spinal nerves continue down and exit at their appropriate levels between the vertebrae. In other words, although the spinal cord ends up here, between the L1 and L2 vertebrae, the spinal nerves will still continue down and exit at their appropriate level. For example, the L5 spinal nerve will exit beneath the L5 vertebra. Another fact you need to know is how far down the dural sac descends. Knowing where the dural sac ends is very clinically relevant because when a lumbar puncture is performed, the physician is trying to extract CSF, which means they want to be within the subarachnoid space. However, they want to insert the needle below the spinal cord so as not to cause spinal injury. In other words, lumbar punctures are traditionally performed at the L4, L5 vertebral level or the L3, L4 vertebral level. There is another similar procedure called an epidural anesthesia. For an epidural anesthesia, the needle is inserted above the dura mater, so within this epidural space. In this type of anesthesia, the needle does not puncture the dural sac and does not enter the CSF. So it would just enter in like a lumbar puncture, but then it would just go up instead of puncturing the dural sac. The different clinical scenarios in which you would perform an epidural anesthesia versus a lumbar puncture is not nearly as important as knowing the anatomy of this level of the spinal cord, as shown in figure 8.12. Another thing to know is that clinically the physician will use landmarks on the outside of the body to guide the lumbar puncture. One of the most important landmarks is the iliac crest, which lines up very well with the L4 vertebral body. You can see that if the clinician can find the iliac crest, they can find the appropriate lumbar level in order to perform a lumbar puncture or an epidural anesthesia. It's important to memorize the layers of this image, so let's do a practice question without the labels. So let's say a patient is about to receive a lumbar puncture. After puncturing the ligamentum flavum, what layers must the needle penetrate before entering the CSF? So, as you recall, the clinician will find the iliac crest, I'll just write IC, which lines up with the L4 vertebral body, and then he will puncture between the L3 and L4 vertebral level, let's say, and after puncturing the ligamentum flavum, which is this blue part, you will enter the epidural space and then puncture the dura mater and the arachnoid mater before finally entering the subarachnoid space to enter the CSF. So let's just review the basic things about the spinal cord that you need to know. So the spinal cord contains white matter, which is on the outside, and gray matter, which is on the inside. And the white matter sends information from the brain to the periphery and from the periphery to the brain. The gray matter is actually where these cell bodies are, and these are unmyelinated, which is why they are gray. Each spinal nerve exits above its corresponding vertebrae down through C7, including C7. However, spinal nerves C8 and lower exit below their respective vertebrae. And also remember that lumbar punctures are performed at the L3, L4 vertebral level or the L4, L5 vertebral level. And that concludes this section.